So today we are going to be talking about lesson 6.7. Lesson 6.7 of chemistry honors is molecular geometry. So it's not the geometry that we're used to. It's rather the geometry of how bonds are made. VESPA stands for the valence shell electron pair repulsion theory. And basically, due to the repulsion of electron pairs, molecules adjust their shapes so that the valence electron pairs are as far apart as possible. So shared and unshared pairs of electrons repel each other, but unshared pairs repel more strongly than shared pairs. All covalent bonds are the same, so single, double, or triple bond, it only goes up to triple. And the shape of a molecular ion is the result of the shared and unshared pairs of electrons being placed as far away from each other as possible. So a shared pair is a bonded pair, and an unshared pair is a lone pair. This is an example of a trigonal pyramidal. We'll talk more about that, where you can see that the red is the lone pairs and the black are the bonded pairs. NH3 is also known as ammonia. Ammonia is actually a highly toxic compound. So, just in case you want to know what NH3 actually was, it's ammonia. And we will talk more about trigonal pyramidal in a little bit. So, we're going to talk about these 9 different bonds throughout this video. And there's actually 8 separate types of them. But 2 of them are like kind of the same, but also kind of, not the same. Mr. Aderbug actually told us that that there were actually less than 8, and he kind of lied. But on the other hand, he was kind of true. There's only 7 names, but one of the names has two different types. So it's like either 7 or 8, depending on how you look at it. So the first is linear, and we'll talk about 2 linear pairs. The first is CO2. The central atom is carbon. This is the important part. There's no lone pairs, 2 bonded pairs, and a bond angle of 180 degrees. All binary molecules are linear. Same for BEF2, where there's 0 lone pairs, 2 bonded pairs, a linear shape, and a bond angle of 180 degrees. Any, as you can see, any linear shape is hypovalent. That basically means the central atom has less than 8 electrons. Now we have SNSCl2. The central atom is tin. There's 1 lone pair, 2 bonded pairs, and it's bent. I'm pretty sure this is also hypovalent, but I'm not entirely sure on this one. Yeah. Oh my God. I have to go to the basement quickly. Sorry about that. I just had to retreat to my basement. As far as the bond angle for this type of bent, we don't need to actually know what the bond angle is. But there's another type of bent in which we will need to know what the bond angle is. I'm going to be honest, I'd actually cut that out, except for the fact that I don't know how to cut out a video in the middle, only at the beginning of the end. So, yeah. Sorry about that. Okay, example 4 is BF3. This is another hypovalent one. The 0 lone pairs, 3 bonded pairs. It's called trigonal planar. Bond angle of 120 degrees. And why is my camera all funny? Oh my God. Yeah, okay. Okay, now we're closer in. And never mind the fact I've almost blinded myself. There we are. Okay. Now we have methane. Highly toxic gas. Contributes to lots of greenhouse gases. The 0 lone pairs, 4 bonded pairs, is a tetrahedron. While you might think that the bond angle is 90 degrees, there's some weird physics involved that makes the bond angle 109.5 degrees. Ammonia, trigonal pyramidal. There's 1 lone pair, 3 bonded pairs, central atom of nitrogen, and a bond angle of 107 degrees. This lone pair is going to push those bonded pairs closer together. Water is an example of bent type 2. A bond angle of 104.5, 2 lone pairs, 2 bonded pairs. These 2 lone pairs are going to squeeze these 2 bond pairs together. Now, water is not bent. If water was bent, much like if liquid water was less dense than solid water, we would be dead. Salt would not dissolve in water if that was the case. It would be ultimately, a very, very sad world. It would be a bad world, one that we don't want to live in, if that were, actually to be the case. So don't think that water is linear. Water is not linear. If water was linear, you wouldn't be alive. Water is bent, and that's how you're alive. Okay. Example 8. PCl5, central atom of phosphorus. There's 0 lone pairs, 5 bonded pairs. This is what we call trigonal bipyramidal, because there's kind of 2 pyramids. The bond angles are the 120 and 90, and this is hypervalent. The central atom has more than an octet, or 8 electrons. And poor sulfur, it's got 12 electrons, another hypervalent electron. The 0 lone pair has 6 bonded pairs, and it's called octahedral. So this is, again, a little bit of a view, but it doesn't show the bond angles. And the bond angles for an octahedral is 90 degrees. So then we have some other stuff that we talk about. We actually didn't get to resonance structures because I derailed the class. But, oh my god, this is going to be fun. I am actually going to be the first one to expose resonance structures. I will be the first one to read it, not Mr. Adabug. So, if you're watching my YouTube videos, good on you. You'll have a head start. So, resonance structures. We sometimes encounter molecules and ions in which the experimentally determined arrangement of atoms is not adequately described by a single dominant Lewis dot structure. Ozone is a good example of this. It's a bent molecule of 2 equal OO bond lengths. The single structure itself cannot be dominant because it requires that one OO bond be different from the other. We expect the double bond to be shorter than a single bond, so we could just easily put the that bond on the left, and there's no reason for one of these Lewis structures to be made dominant because, equally valid representations. So, resonance structures are individual Lewis structures in which 2 or more Lewis structures are equally good representations of the molecule. You could see that right here. Another example is sulfur trioxide or benzene. It looks like benzene is C6H6. So why do we need to know the shape of a molecule? And this we did get to. It's to determine if it's a polar molecule or a non-polar molecule. Symmetrical molecules have an even distribution of charge. So linear, tetrahedral, trigonal planar, trigonal bipyramidal, and octahedral can be symmetrical. That doesn't guarantee that they are symmetrical. But if it's not on the list, it cannot be symmetrical. Bent cannot be symmetrical. Trigonal pyramidal, what ammonia is, cannot be symmetrical, cannot be nonpolar. Think that's it. So you know, and again, this is difficult concepts in some cases. The interpretation, I'm actually struggling a little bit on it. I have a concession to make. I only got an 86 on a periodic table test, despite being relatively confident in my abilities on it and making the YouTube videos. So, if you're confused, then yeah, maybe don't. Maybe like, I don't know. I'm better with some topics than others, and I feel like the ones I can explain more easily are usually actually the ones I do worse on the tests on. So I will admit that I'm struggling on this a little bit, and I'm not invincible in the land of chemistry. But, it's still fun to make these videos, so unless I'm directly told to stop by someone important, I'm going to keep making these videos on YouTube. So I hope that you enjoyed anyway.